Yeah. So sometimes when you're reading the question, know the type of question that we have. Right. So question 3, by reading, I see that question 3 is binomial. So that's a binomial question. Right. Now, because it's binomial, we need to find, or we need certain information. So we need to know what n is. Sorry, they had 10 women. So the n is 10. Okay, so how do you know it's binomial? Now we know it's binomial because in the binomial, the bi here, oh, so the bi means things that have 2 outcomes. So here they're talking about never married and then married. In other words, once they talk about the fact they are 40% were never married, then it automatically, so 40%, 50% never married, it means automatically 60% married. That's the implication for that. So binomial, usually things that would have only 2 categories. So usually the person will give you only 1 category and then you come out with the other category. So, but this is a little tricky question. So let's be careful with this. So n is 10. We know they said 10 women. That's good. Now, p is 0.40. Remember that this is for those that are never married. Now, we don't, let me write Q here. Q will be 6%, right? 0.60, and this will be people that are married. So if 40% were never married, then 60% were married. In this case, like if you are in a binomial situation, you have to think of one group or the other group. Okay, so now the question says X is at least 8 married. Now, you always, in a binomial question, always write out the values that the X pairs to. So at least 8 married means either 8 married, 9 married, 10 married. All right. So 2 ways to do this problem. You could do what we call PDF. 8 do the PDF for 9, do the PDF for 10, and then you add them up. Right. Another way is to use what we call the complement. In other words, the X values ranges from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? This question said we are looking for 8 to 10. We are looking for 8 to 10, which means that from 0 up to 7, what we call the complement. All right, 0 to 7 is what we call the complement. Now, anytime you are doing you have like a complement situation, then the probability that you are looking for will be 1 minus the complement. All right. Who raised a hand? I can't see that. So go ahead and talk.
I was confused. You said that you could either do the complement or you could do the normal PDF.
Yes, if you're doing a normal PDF, then 3 times.
Yeah, okay. So then when I plug that into my
Oh, sorry,
calculator,
I said normal. I'm sorry. You could do the binomial PDF, not normal. So binomial PDF, take N, P, and then the X. So you N is 10, P is now the P here you're gonna use 0.6, 0.4, and then the X you're gonna do for 8. Then you come and do for 9. Then you're gonna do 10. When you finish, you're gonna add 3 answers. Then you get it up.
How do
okay.
you
And
get to the binomial
say
PDF?
again.
How do you get to the PDF on the calculator? second. Okay, right. I forgot about that.
All right. So you can do the complement for this problem, right? So this side from 0 to 7 is the same as binom CDF of 10.6, 7. All right. So do the binom CDF for 10.6, 7. Could someone do that for me? So let's see.
I got
Can
0.953.
you said 0.953?
Yeah. If you round it, then it's
Oh,
0.954.
okay, so hold on, let me see. So that alone, so the complement is 9, you said 9.5?
Wait, up until 7 you said to do?
Yes, so you're gonna do binom CDF 10.6, 7
Oh,
because CDF7, the moment you write CDF7 here, it means from 0 to 7. Like
oh,
it
so then
does all the addition for you.
it's 0.833 then.
Okay, so 0.833, right?
Yep.
So now you're gonna do 1 minus the complement, probability of the complement. So this will be 1 minus 0.833. And I believe it should get this answer.
Got
Two
that answer.
ways, very good. So 2 ways to do this problem. All at least kind of questions, you can either list them, or you can either list them and do them individually using PDF, or you can use the complement. Usually the easiest way to do the complement is to write from 0 to the end and then box the at least part, and then you will know where the CDF should be. Okay, now note that this question is one of the hardest questions. Why? Because you were given the married to be 40%, but then the question is asking you, you were given the never married to be 40%. The question was asking you those that were married. So you have to use 0.6 in your calculation, not 0.4. So when you are doing the problem, please note of some few details that comes with it. Okay. Any question on this question 3? All right. Go with that. I think there are a couple of binomial questions. So then, all right. Now question 4. All right. Now question 4. This is a very interesting question because it asks you for a z-score. So the question is asking for z-score. All right, so we want z-score. Now we know z-score is a value minus the mean divided by the standard deviation. However, this is a situation where the value is a sample mean, which means that this is a question about sampling distribution. Remember when we learned the sampling distribution, we x bar, and we have sigma x bar. Mu x bar we said is mu. So in this case, the mu x bar happened to be the mu, which is so the mean is 200. So mean is 200. So over here, this will be 200 over here. Now the value, it's the 180. That's a sample mean. So the value is the 180. But what is the standard deviation? The standard deviation, because it's a sampling distribution, the standard deviation is sigma over square root of n. And that is why they said something like n equals some 9 individuals. Right? So they gave you the standard deviation and then they gave you. So for most questions, they will give you standard deviation and then they will tell you a random sample. Always more so on the line of sampling distribution. I think on the line of sampling distribution like this. So in this situation, then we are going to put the sigma, which is 24, divided by square root of 9. So that's 24 divided by 3, that is 8. So your standard deviation will be 8. So you're going to have 180 minus 200 divided by 8. And okay, this is what the answer we choose. Any question on this? All right, so I'm good with this. Let's go to the next question. Now, in this question, it says we should compare. You compare scores using z-scores, right? So they gave us 2 test scores. So let's say A and then B. Now, the z-score we know. So this is comparing z-scores. So z-score is value minus mean divided by standard deviation. So in this case, let's see, the value is 220, the mean is 200, the standard deviation is 21. May I have someone can calculate for us? And in the second case, the value is 90, the mean is 80, the standard deviation is 8. So could someone be kind enough to do the calculation for us?
Yeah, for A, it's 0.952.
Okay. And then someone B, if you have it, you can let me know.
For B, it's 1.25.
1.25. Okay. So when we're comparing, suppose 0 is here. So 0 is like S average. And then 0.9 is somewhere here, which is the 0.95. And then the 1 other one. So this is A and this is B. So in a test, the far away on the right you are from the test, the better your performance, 1.25. So this is better. The B is better. This is better. So that is test that has a 90. It's better. Okay. Now, the third question 6. That's an easy question, right? I gave you the stations. Rho is for mean. Rho is population correlation, and then R is for sample correlation. So that's straightforward. I don't have to worry about it. Okay, good. This is a good question. Now, in question 7, it is a give question means we call them conditional probability. So for conditional probability, using conditional probability is easy. Why? Because it just forces you to focus on the given situation. In this case, they said we should focus on the seniors. So we are only acting as if this is the only data we have. If this is the only data we have, the total is going to be 43. So the same of the seniors that we have here, how many are? So there are 6 out of the 43. So 6 out of 43, then you get your answer. Okay.
Wait, I was confused. So you said that because it's asking for given, it's a senior. Is that the same? Like, is given the same as and?
Given is not end. All right.
Okay.
Given always means focus on the subcategory that you have been given. In other words, act as if all the rest are not there. Act as if these are not there. Act as only group of students you have is the seniors. That's what giving means. Is it making sense?
Yeah, wait, do you have questions of it being like and or?
Yeah, there are n on or on this, so we will get
Okay,
there.
thank you.
So now, but by the way, right, and yes, is the intersection. So what they say, science, and junior, right? Science and so you act as you are moving on the science line, and you are moving on the junior. So where crosses each other? That is N. Is it making sense to you?
Yeah, thank you.
All right. So N is always the intersect of the one from the top and one going across and one going from left to. So where the two crosses is the. So if the question had just been science and junior, then we're going to say 6 power 100. All right. The only time your denominator is not the overall, remember the overall denominator is 100, right? The only time your denominator is not 100 is a given situation. Because once it is given, it's restricting you to only a section of the data, not all the data. Okay. Now, question 8, it's a normal. So this is a standard normal, right? So that's standard normal. This is made up of two sections, a negative infinity and a positive infinity. So call this A and call this B. So as far as A is concerned, just go to the calculator and do the normal CDF. Remember normal, we always use CDF, nothing else. All right, normal CDF. Then from A will be from negative 1 million to negative 1.1. It's a standard normal, so the mean is 0, standard deviation is 1. If someone can do that calculation for me, I'll be happy. So you get the normal, you go to second verse, and then you plug in the values. Now the B part is normal CDF. Now B, this is a from, and this is the to. A, this is the from, and this is the to. All right. So B is from 2.03 to infinity 1 million, 0, 1. So if someone has an answer, you could just let me know, then I can put it together. Anyone?
First one is 0.129.
1, 2, what?
9.
We need 4 numbers.
0.129.
Just like that.
Mm-hmm.
All right, the second one.
0.0211. Or if we're rounding up, 0.021.
Usually, okay, and 0.0211. That's what we had, right?
Yeah, or if we're rounding up for the first one, it'll be the last number will be 2.
There should be a 2 here, you said.
No, for the second one, sorry.
But this should be 2.
Yeah.
First one, could we double check that again? Because usually it should be 4 digits.
The first one is 0.1292.
92.
Yeah.
Okay. So you're going to add the 2 numbers and it will be something closer to this. 15. Okay. So we are good. Now, this is a question. All right. Now, this is the question that have standard normal is to the right of this number. Anytime you see a normal distribution question, draw the line, draw the bell curve to help you. So draw the bell curve. The middle is standard normal, so this is 0. Now, negative 1.25 will be here. And they are saying that to the right, right? So you're going to shift all the way to the right. Shading all the way. So it's going to infinity. So then we could do normal CDF from negative 1.25 to 1 million. Standard normal, so this is 0 and 1. And then I believe you will get this value. We good? Okay, let's go to the next question. Question 10. That is a little interesting question. Once in standard normal, so that's good. So draw the bell curve. When you see to the right or left, always draw the curve, right? So put 0 here. Now 12 right of 12% to the right. So means that the right area is 12%, which is 12 here. Right area is 12%. Now you always have, if you don't, you always have to know the left area. So if the right area is 12, what would be the left area? Someone tell me.
88.
Excellent. So we could write 88. And anytime you are looking for a z value, if you don't know the z and you are looking for the z, the function on calculator that you use is an inverse norm, right? So, so you're going to say z, so z equals inverse norm, put a 0.88 there, 0, 1, and that'll give you the answer. Somebody could just double check for us, please.
Yeah, I got that.
Excellent. Excellent. Now, question 11. Now, this is a big question. You are guaranteed to have a question like this. Yes. All right. So let's see what this is about. Well, I see to the right, and then I see a percentage. So start with a percentage and then the diagram that should go with it. All right. So when you see a question like this, it says find the mean or find the x or find the variance. Always standard deviation for, always start with the diagram and then shade what they are telling you. So if I have this diagram, and let's start with like a standard normal, 5.84% to the right should be something small here. So I could say right area, it's changes to a decimal. So that's 0.54 side. So we are looking for what z is here. Now you have to get the left area. So someone do the calculation for the left area and let me know. Now note that the left area will be 1 minus something, right?
I got 0.9452.
Oh, 0.9452. So I'm not going to double check because I trust you so badly. All right. So now we're going to just do inverse norm. So let's say the z that we are looking for will be inverse norm. Inverse norm. You have to use the 945, 1. And someone do this calculation for us.
I have a question.
Yes.
For the left area, is it 1 minus, like 100 minus 0.548?
No, it should be 1 minus, not 100. Because we've changed to decimal, right? Probably the maximum is 1, right? So it's going to be 1 minus 0.0548 to get that number.
Okay.
I got 1.5999936.
So we could make it 1.6,
Okay.
right? So the z is 1.6, but that is not the final answer. Now, remember that there's a formula in normal, say z equals x minus mu over sigma. So that's the formula you're going to use. Already, the z we just got is 1.6, right? Now, they said we should find a mu. So for sure, we don't know mu. But they said the standard deviation is 5. So obviously, the only number that is left is the x value. All right, so the 78 is x value. So x is 78. And we work it out, multiply both sides by 5. So 5 times 1.6. And then that is 78 minus mu. And you're going to have 5 times 1.6. Is it 8? 8
Yeah.
equals to 78 minus mu. So subtract 78, subtract 78. So that would be minus 70 equals to minus mu. And then mu will be 70.
I have a question. When I entered that into my calculator, the inverse norm, it gave me an error.
Did you put a decimal point?
Yes.
0.94,
Yeah.
comma 0, comma 1.
Yeah.
All right. So when you have that case, just clear and back and then create. You can do. Usually you could do second. So it will take you out of that function. Then you can come back and do it again.
Okay, because for mine, it's not like, well, it's not like I do the commas. It has like area, mu, then 0, or the standard deviation, and then paste.
Okay. So yours gives say area. So to see area, put 0.9452.
Okay, I did that.
Mu 0.
Mm-hmm.
Sigma put 1. Then you do paste.
Okay.
And then you enter. After you do paste enter, when you enter, I think you enter twice. When you enter the paste, it will just show you what you put in. And then
Okay.
you're going to enter again.
Okay, I got it now. It worked.
Excellent, excellent, excellent. Okay, now, so this is one of the hardest questions. Why? Because it is a two-step question. Number one, you have to find the z first. Number two, you have to use the z formula, the actual z formula to find what it is. Right? So you have two of these questions coming in the test. Okay, so take note of it. Okay, so let's get to the next now. I think I realized that the mu here should be 55, not 50, and then this should be 50. This is 50, and then this is 55. Let me say mu is 55. Let me raise it, and then yeah. Okay, so this is 5555. But it's a same type of question though, right? So like I told you, see a percentage and you see lies to the left, draw the standard normal and find the z of these first. Okay, so first question like this, draw your bell curve. Do the standard normal type because that's an easy one to draw. And then they saying that 10.56 to the left, right? So this value goes, this goes with that. They go together to the left. So you go come over here and then say left area is 0.1056. That's what that means. So you're asking yourself what Z should come under the line. So the Z we are looking for, because this is already the left area, we don't have to worry doing anything. You only worry to find something else if it is the right area. If it's the left area, you just go ahead. Problem. All right. So the Z here will be inverse norm. And as we are doing this, take note of how we find inverse norm. You do inverse norm when you are looking for a Z score or you are looking for X value. So how I draw the line and I say what Z is here, then it's automatically an inverse norm. So I'm going to put 0.1056, 0, 1, and I'm going to ask whoever has your, and you could work it out for us, and then I can write in.
Yeah, it's negative 1.25.
Okay, negative 1.25. So this is step 1. Step 2, you know Z is X minus mu over sigma. So we're just going to plug in the values. Z happens to be negative 1.25. Now, X is going to be the 50 here. The mu will be 55. The what? Oh, they said we should find standard deviation. So we don't know sigma. We don't know this. All right. And also note that we can subtract the top, so negative 5. Now in algebra, you can cross multiply. So we could say that negative 1.25 times sigma to give us negative 5. Then you can divide both sides by negative 25 divided by negative 1.25. So could someone do the division for us?
Yeah, it's 4.
Okay, so then that is 4. So sigma happened 4. Okay, now let's see another one. We're progressing really good. So here, this is a normal distribution question. To give you the mean, so this is one of the straightforward one. And you're gonna have a couple of them. The mean happens to be 15.2. It said more than 14, so 4 comes before 15. So 4.5 more than, so I shade everything. So it means I'm going to infinity. So this is a regular normal CDF. So normal CDF, or from 14.5 to infinity, which is 1 million, comma, mean is 5.2, standard deviation is what? 3.1. I don't know what is going to give you, but our source, it will be this. Any confirmation?
Wait, so you just plug that into your, like you drew your bell curve and then you use the mean and the standard deviation?
Yeah, because the way it works is that the first value, the first value from the left is your from, or in the calculator say the low. And then where it's going, the final on the right is a 2, or to say the upper. So from is the lower, 2 is the upper. So lower and lower. So you always think of it from left to right.
Wait, how did you know that the 14.5? Oh, because it says more than. Okay, never mind. Thank you.
Okay then. All right. So let's question. Yeah, that's the other famous question. So this is definitely, those are definitely so female or pose. Now, so all questions means it's called the addition rule. All questions are addition rule. Addition rule means that you're going to do 3 things. So you're going to say probability of, let's say, female, or probability of female or O's, right? Maybe I could have done O or F, will be probability of the females plus probability of the oppose minus probability of female and oppose. Because probability of A or B is probability of A plus probability of B minus probability of A and B. So this is very, very, very important. All right, even though all your tests are open technically, it is good to memorize this formula. Anytime you see all, this is the formula you're going to use. No other formula. This is the only thing you're going to use. All right. So all means you do P of A or B means P of A plus P of B minus P of A. So let's now understand what is going on. What is the probability of females? It means all females. Now all females made up of 50. So we're gonna write divided by. So we write 50 divided by 120. Now note we are using 120 because this is not a given where it's written. Only time you are repeated, the only time your denominator will change is when you have a given situation. If it is not a given situation, it is all n, then it will always be divided by the overall total, in this case, which is 120. Now, plus all the opposed. Now, the opposed is 81, right? So, plus 81. So, somebody will be doing the calculation for us as we go. Minus and. And means the intersect where female and female oppose. So there are 36 people who were female at the same time they oppose. So minus 36 over 120. So you could do 50 minus 81 minus 36, put the answer down and divide the result by 120.
Got 0.791.
0.791. Okay, so that is 0.791. So that is why this came the answer. Now, if you can understand this, no all person can beat you. Right? So this is a good one because it doesn't matter if there are 3 questions. Like usually I put a minimum of 2 all questions. So at least you know for those you have it right because you know what to do. Okay, question 15. Question 15, looking here, it looks like this is a given question. Now remember, given always, so given company A. So it says that act as if the only data you have is the company A data. Ignore every other thing. Right? So you are only focused on this as if the whole data is made up of this, nothing else. Which means that your denominator will be 1 or 2. Right? So the given company A means that focus only on company A and ignore all the other data points. And the person says, what is a defective in that group? There are 16 defective in the one, so it will be 16 over amount. And someone just double check if the answer is correct here.
Yeah, I got that.
Thank you. Okay, so let's go to the next one. We're pressing well. So question 16, in question 16, that's a straightforward question. Says x greater or equal to 0, 1. So we're going to add 5 to this to that, right? So that will add those ones, 0.5 plus 0.2 plus 0.1, that gives us 0.8. Okay.
Wait, you go back to that one really quick. I just need to see the
Yes.
answer.
How
You
come
said
you?
0.5. Sorry, go
Oh,
ahead.
sorry. No, I was no. You go ahead. You can go first.
No, I'm sorry. I just didn't realize I was on mute. Sorry.
Oh, I had a question. How come you're not using the other point to value for the -1? How come you don't use that?
Okay, because this says x is greater or equal to
Oh.
0.
Okay.
Yeah, that's because of what the symbol is saying. But that's a good question. All right. Now, this is so when you question, they give you a percentage and they give you a category. So they are saying 68% wear glass for driving, which means that other 37% do not. All right. So automatically, what kind of problem do you think question 17 will be?
Is
What
it
type of question?
binomial?
Excellent. So that's binomial. Because binomial, they give you one category and they want you to apply the other category. So what's binomial? You need your N, you need the P, you need your Q. All right. So N, they had 100 out of 0.3 wear glasses driving. So 0.37 do not. They don't wear glasses driving. Now the good news is that this question really doesn't want us to do much. We want the mean of the binomial. We want the standard deviation binomial. So that is one of the formulas I want you to know. So if you have binomial, it asks you for the mean. Mu is just a time. So in this case, all you're going to do is to say 100 times 63, and that is 63. Now they want the standard deviation. The standard deviation with the sigma is the square root of the variance, which is n times p times q. So this is one of the formulas when you get as a symbol, create these things by your side. So you don't going to waste time trying to find out where it's hiding in your, because you definitely don't have things like this. All right. So have this formula right somewhere by you, so you don't waste too much time trying to open your notebooks and stuff as to where the values, where the formula is. Right. So maybe I would create like a formula by yourself. So this would be 100 times 0.63 times 0.37. And I don't know what we have somewhere here, so I'll choose that.
Do you
So
mind
it's,
showing it in the calculator, the binomial function?
see again.
Would you mind showing the binomial function in the calculator just so, because I don't want to get messed up with like the other.
When it is binomial, right?
Mm-hmm.
It asks you for mean and it asks you for standard deviation. You don't need a binomial function. All you need is a formula.
Oh, okay.
All right. All you need is a formula. So that formula is programmed in the calculator. So that's why I was saying that write these formulas somewhere. When it is binomial and they're asking for mean, this is what I have to do. When it's binomial, they're asking me for standard deviation. This is what I have to do. That's it.
Okay, thank you.
Very good. Very good. So this is very fruitful. I'm happy we have this. Okay, so question 18. This is still part of question 18. Call that discrete probability function. All right, that is called discrete probability distribution, something like that. Now, all you're going to do is to go to that, then you go to edit, then it shows you L1, L2, put in the X values on the L1, put in the P of X values on the L2. So that's step 1. Then step 2, after you put in the values, which I hope somebody's doing for us, go to start again. At this time, you're going to cut. And then what you doing here, you're going to select one var start. Now, when you select one VASTA, it's going to ask you, I think, for, I don't know, X values or X lists, I don't know, some list. You're going to put the L1, and it's going to ask you for free list in L2. Remember that L1 is the same as what? L1 is second. If it's not there, L1 is second, then 1. Then L2 is second, then 2. So then you say calculate, and then you are looking for X bar, and then you are looking for sigma X. Did anyone try for us?
Yeah, I did it. The X bar is 1.14.
Okay.
And then the standard deviation was 1.04.
Okay. All right. So those are straightforward calculator thing. And one of the things I would encourage you, when you see the problem, know what to do. Because that will save you a lot of time. Definitely will save you a lot of time. Okay. So I have a question here. I have a stage, and they gave me a category that this percent they favor building a police station in their neighborhood. What does this question feel like? What does it feel like? What type? If 64% favor building a police station, substation in their neighborhood, then what? Could someone be filling that gap? Then what?
Then you do the 1 minus 0.64.
All right. So this is definitely a binomial, right? Because binomial, they give you one side of the story, and then you want, just by you reading, you can imply that 36% do not favor. So in this case, it's binomial. You need n. N is 14. They say. Then you need a p. That's 64. Those that favor. Those that favor. So they favor building the station. And then you have q. That's 0.36. Those that do not favor. Okay. Then they say x equals to 8. So what should we use? Someone give me a, you know, it's binomial, it's asking for probability. So what kind of binomial should we use? Okay,
TDF.
PDF. So you do binom PDF. PDF do for only one number. They want you to do only one number. Now, so that will be n comes first, 14, followed by p.64, and then that's it. Now, if you do CDF, you know what it's going to do? It's going to do 0 plus 1 plus 2 plus 3 plus 4 plus 7 is 2. So CDF of 0, CDF of 1, 2. This is not a CDF question. All right, so just looking for one exact value.
So you do the function in the calculator when you're not given the standard deviation?
When it's asking for a probability.
Okay. It's asking for, okay.
All right. In binomial, usually there are 3 questions they ask: a probability question, or a mean question, or a standard deviation question. Also note that if it's a probability question, it could be PDF, CDF, PDF. When you trying to get the answer for each number,
Okay.
trying to
Wait,
get the answer only for 8. Yes. Ask your question, please.
Yeah, so if it says like less than, like it kind of goes on what she was just asking. But if it's like say like more than 8, do I just pick like
Excellent.
3
That's a
random?
question. That's a question, right? So let's practice that too. So suppose they say x is more than than 8. So more than 8, you're going to ask yourself, what does more than 8 means? Right? One way you could do it, let me write from 0 to 14, because n is 14. And now so we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Right? So more than 8, what number? Tell me.
Like 9, 10, 11, 12, 13, 14.
Okay, so now 10, 11, up to 14. So one way you can do this problem is to do for 9, write the answer down, do for 10, write the answer down, do for 11, do PDF for each one. It is too, if you take a test, it is not an efficient way. So you're going to require the numbers that came from 0 to as the complement. And anytime you have complement, you can use a binom CDF. So you do binom CDF, put the 14, the 64, 8. Now 8 is coming from the last value before the person number. All right. And also for a complement, you answer 1 minus the probability of it. So whatever you get from here, let's say you get A, then you're going to be 1 minus A, or 1 minus the answer, whatever the answer will be. So that's a very question that you ask. Very good one. And this will take you less time than doing one at a time and then writing the answer down and then go to the other one. Because sometimes when you're writing the answer down and you miss, then you could get the whole thing wrong. Okay. Now, so 20, we almost there. That's good. Just 29 questions, so we're almost there. Now, here, it's a normal question, so I'm going to draw the curve. It said the mean is this 15% or lower 15%, right? So that is area to the left. So 15% is not that right here, something like that. So you're going to say left area. Left area is 0.15. Now, these are good news. Why? Because if you have the left area, you don't have to worry about anything. So this will be X. So this is an inverse norm question because you are looking for the number, right? You are looking for the value. Inverse norm, the area to the left is 15. The mean is 1200. The standard deviation is 120. So somebody do this for us and then let's write the answer. Anyone? Anyone here?
Yeah, I got 1075.6.
Okay, so that's why this is the correct answer. That's good. So 107. So this is correct. Okay. Now, so know how inverse norm questions look, please. Okay. All right. So here it is known that I see produce a certain amount of now. Someone tell me what type of question is this? 6% are defective. It implies that what?
Would it be binomial?
Excellent. So this is binomial. Very good. So this binomial, so you need N, you need P, and then you need Q. Okay, yeah, 10 light bulbs, so that's good. The defective is 6, so I'm just going to write defective here. And then Q will be 0.94. The 94 different. Now they say X is at most. Always write out what X means. So it is 0, 1, 2. So because this is starting from 0 and ending 2, it is a candidate for binom CDF. So you're going to do binom CDF, and Q is 0.0, C is 0.06, and then you put 2 here. Now, always the CDF, one put C starts from 0, the number, right? So C means from 0, whatever number there. And I don't know the answer, but I'm suggesting that I have it correct here. Of course, remember that binom is second verse. Second verse. Okay, we get 22. Beautiful question. So 22 is standard normal. They want us to find probability, so we know we are working normal CDA, but we have to draw the diagram. So start with a parabol diagram. 0 is in the middle. Two numbers. One is 3, and it's to the left. You're shading to the left. So you have negative infinity. So let's call this A. And then the other part, it's 3, and it's go to the right. So let's call B. So this is, you're going to find A, you find a B, then you add. Now, luckily, because this is almost the same, you're going to have, you could just do 2 times whatever answer you get for the A. Because A is a mirror image, is a mirror image of A. So what do? You do normal CDF from negative infinity to negative 2, 3. The standard normal, so that's 0 and 1. I don't know what it's gonna give you. It looks like 1.4. No, I can say first. Somebody.
I did
Anyone
not
help
get
you?
that. I got 0.0099.
0. Okay, let me just write it. You said 0, 0.99. Could
Yeah.
someone double check for me? Negative 1 million, negative 2.33. Anyone else is checking for us? Actually, yeah, this cannot be. I may have shaded it wrong. This might be like the B, the second one. It might be this. All right, not this. Did anyone double check?
I just did it again and I got the same thing.
Okay, so that's fine. Now, so that is for A. You're in this normal CDF from 2.33 to 1 million. 0, 1 to give you the same value. Then when you add them, that'll be 0, 0, 1, 9. So the answer should be this.
Did you just add this together?
Yes.
Okay.
Usually all problems require some addition. Okay, so let's see. We have this question. They want us to find probability that's a mean. So when the question is such that it's asking you to find a mean, it is automatically a sampling distribution question. So all sampling distribution question, they're going to give you some n, like n. So for example, here they took 50 people. Now you need your mu x bar, and you need your sigma x bar. The sampling distribution, these two values are crucial. Mu x bar is a mean. In this case, they said average is this. So the average is 196. The standard deviation, they said the standard deviation is 22, right? But because it is sampling distribution, that'll be 22 divided by
Wait,
square root.
shouldn't that be 50, not 500?
You know, you are very right. I don't even know how I managed to
No, it's
make
okay.
that. Yeah. So thank you so much. So that will be divided by 50. Now let me show you, let me say something here. Because you're taking a test, you can decide to do this, or you can decide just to calculate. Let me show you how we would do it. All right. Now remember, now let's see, draw your bell curve. We have 196 in the middle. Then they say we should find probability of less than 200. So 200 will be somewhere here. 200. And then they said less than 200. So we're going to shade everything below. So we know negative infinity is involved. Therefore, normal CDF from negative 1 million to 200, mean 196, standard deviation. You can put the whole thing here. The calculator is smart enough to do that portion for you. Where you see the sigma in your calculator, and this is me, this is upper, and this is the lower. You can put this whole value calculator to respect that and do that problem for you easily. And could someone just double check so I make sure that my answer is correct here?
I got that answer.
Thank you. All right. Great. Just some questions. Oh, let me come back again. Once again, if they give you like a sample size, they give you sample size and the actual probability of a mean, know for sure it is a sampling distribution. Okay. So let's see the next question. So they asking for probability, talk about a mean, they give you sample size. So this is definitely a candidate for, they give you sample size, probability of a mean. So it is a sampling distribution question. Now, when it's sampling distribution, you need the n, then you need the mu x bar, and then you need a sigma x bar. Those are the key players. N is 36. 36 women that was the mu x bar is always like the original mean, so that is 264. But the sigma x bar will be sigma over square root of sigma happen to be 15 over square root of 36. Now you can calculate this or you can wait. All right. So draw your normal curve. We draw our normal curve. 264 is here. Now they want 264, this number again, and 266. So they're asking us to find these values. So normal CDF from 264 to 266, the mean is 264. The standard deviation is 15 over square root 36. So this is sigma, this is mu, this is the upper, and then this is the lower. And if someone double check, that'd be great, because I just want to make sure that I select the right answers.
Yeah, that's correct.
Thank you. So that's great. All right, 25. Now,
Wait, what was the
25.
last one? I'm sorry, I missed it. It was 0.2881.
Yes, yes. Okay, now, then I think what I can also do is post this that I've worked on Blackboard, so you can also see it. Like the things I'm working, like just to post it on Blackboard also. Okay, so here, let's see, we have a mean, we have a standard deviation. Oh, there's a sample size. So usually when they give you sample size, think more of sampling distribution. All right, so sampling distribution. And in a mu x bar, in a sigma x bar. All right, and they took 30 people, mu the 920. Now this is sigma over square root of n, so that will be 190 divided by square root 30. Oh, it looks like that's all they're asking us, right? So mu x bar is a mean, and then so someone check if this should be 34.69.
That's what I got.
Okay, so this answer is definitely correct. All right. So this is the last about 126, right? Oh no, there are 29 questions. Oh, our famous friend. Oh, this is all question. So all always means addition rule. Man knows. So we want probability of man or no smoking. But let me write NS. So that will be probability of the male plus the probability of all the no smoking or non-smoke minus probability of man and non-smoker. All right, so this is end. So all the men, let's see, all the men, how many men do we have in total? 210 over 433. All the non-smokers, we have 322 over 433, right? So all the men is there, all the non-smokers. Then where the men and non-smokers overlap. So there are 135 who were and non-smokers. So we're gonna do minus 135 divided by 433. So we need someone to kindly do that for us. 210 minus 3 plus 2 minus 135 all over 4. You press equal first, then you do divided by 4.
0.917.
0.917. This is correct. Excellent. 27. Okay, let's see. Even all this question means standard deviation. What percent of the boys? So this is like a normal distribution question. Looks like a regular one. So we have 170 here. Then between, so 170 and 225 in between here. So normal CDF from 170 to 225. The mean, it's 170. The standard deviation is 30. And then that's it. And they want us to change the percentage, so we're going to multiply by 100. Anyone has the answer, solution?
I got 0.4664, and then if you multiply it by 100, then you get 46.64.
Okay. So this is definitely. All right. 27. Hey, we did this already. I don't know whether it's a repetition or not. That's different. Didn't we do something like this?
Yeah, we did that question already.
Okay. So we could leave